Unit 3. Multiples and factors. You are now know how to multiply and divide numbers. Based on this knowledge, we shall learn in this chapter some properties of numbers. Multiplies of numbers. Let us take any of the multiplication tables you have learned in the lower classes. Say that of 7. 7 ones are 7. 7 twos are 14. 7 threes are 21. 7 fours are 28. 7 fives are 35. 7 sixes are 42, etc. We get 7, 14, 21, 28, 35, 42, etc. If we multiply 7 respectively by 1, 2, 3, 4, 5, 6, etc. The products we get are called the multiples of 7. Therefore, 7 itself is the first multiple of 7. 14 is the second multiple of 7. 21 is the third multiple of 7, and so on. Thus, to get the 15th multiple of 7, multiply 7 by 15. 7 into 15 is equal to 105. The 15th multiply of 7 is 105. Let us take some examples. Example 1. Find the following. A. The 16th multiple of 22. B. The first 5 multiples of 32. Solution. A. To get the 16th multiple of 22, multiply 22 by 16. 22 into 16 is equal to 352. Hence, the 16th multiple of 22 is 352. B. Multiply 32 by 1, 2, 3, 4 and 5. We get 32, 64, 96, 128 and 160. Hence, the first 5 multiples of 32 are 32, 64, 96, 128 and 160. Note 1. The first multiple of a number is the number itself. 2. The number is no end to the multiples of a number as there is no end to the numbers. Teacher's tip. Encourage students to make factors and multiples of any number manually. Common multiples. We shall now find some multiples of two numbers, say 4 and 6. Multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and so on. Multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and so on. Observe the above two sets of multiples. You will see that the multiples 12, 24, 36, 48, and so on appear in both the sets. It means that these multiples are common for 4 and 6. We say they are the common multiples of 4 and 6. As there is no end to the multiples of a number, there is no end to the common multiples either. Example 2. Find the first three common multiples of 12 and 15. Solution. Multiples of 12 is equal to 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, 168, 108, and so on. Multiples of 15 is equal to 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180, and so on. Compare the two sets to get the common multiples. We see that the common multiples are 60, 120, 180, and so on. Therefore, the first three common multiples of 12 and 15 are 60, 120, and 180. Example 3. Find the first three common multiples 6, 8, and 12. Solution. Multiples of 6 is equal to 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, 84, 90, 96, 102, 108, 114, 120, and so on. Multiples of 9 is equal to 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108, 117, 126, 135, 144, and so on. Multiples of 12 is equal to 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, and so on. Therefore, the first three common multiples of 6, 9, and 12 are 36, 72, and 144. Factors of numbers. In a multiplication sum, the numbers we multiply are called the factors and the answer is the product. For example, in the multiplication, 4 into 13 is equal to 52. 4 and 13 are the factors and 52 is the product. It means that 4 is a factor of 52 and 13 is also a factor of 52. You can divide 52 by 4 and also by 13. There will not be any remainder in these divisions. We shall here learn about factors in detail. Consider a number 36. Divide it by numbers 1, 2, 3, 4, and so on, and see in which of the divisions there is no remainder. You will see that 36 divided by 1 is equal to 36. 36 divided by 2 is equal to 18. 36 divided by 3 is equal to 12. 36 divided by 4 is equal to 9. 36 divided by 5 is equal to 7 plus 1 as the remainder. 36 divided by 6 is equal to 6. 36 divided by 7 is equal to 5 with 1 as the remainder. 36 divided by 8 is equal to 4 and with 4 as the remainder. 36 divided by 9 is equal to 4. 36 divided by 10 is equal to 3 with 6 as the remainder and so on. 36 is divided by 1, 2, 3, 4, 6, 9, 12, 18 and 36 without any remainder. Therefore, the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Similarly, we can find the factors of any number. Example, find all the factors of A 35, B 48, C 17. Solution A 35 divided by 1 is equal to 35. 35 divided by 5 is equal to 7. 35 divided by 7 is equal to 5. Therefore, the factors of 35 are 1, 5, 7 and 35. B. 48 divided by 2 is equal to 24. 48 divided by 3 is equal to 16. 48 divided by 4 is equal to 12. 48 divided by 6 is equal to 8. 48 divided by 8 is equal to 6. 48 divided by 12 is equal to 4. 48 divided by 16 is equal to 3. 48 divided by 24 is equal to 2. Therefore, the factors of 48 are 1, 2, 3, 6, 8, 12, 16, 24 and 48. C. Try to divide 17 by all the numbers from 2 to 17. You will see that in every division there is a remainder. It means that the factors of 17 are 1 and 17 only. Note, 1 is a factor of all numbers as we can divide any number by 1. Prime numbers and composite numbers. Prime numbers. A number that has only 1 and the number itself as its factors is known as a prime number. For examples, 2, 3, 5, 7, 11 are prime numbers. Twin primes. Prime numbers have a difference of 2 are called twin primes. For example, 5 and 7 are twin primes. Similarly, 11 and 13 are twin primes. Can you find out other examples of twin primes? Composite numbers. Numbers that have factors other than 1 and the number itself are called composite numbers. For example, 6 has factors 1, 2, 3 and 6. So, 6 is a composite number. Composite numbers up to 20 are 4, 6, 8, 10, 12, 14, 16, 18, 20. So, you should remember the following. 1 is neither a prime nor a composite number. 2 is the only even prime number. 2 and 5 are the only prime numbers that end with 2 and 5 respectively. Method of identifying prime numbers from 1 to 100. You can find all prime numbers from 1 to 100 by using a 10 into 10 grid. Make a 10 into 10 grid and write numbers 1 to 100 in it. 1. Cross out 1 because it is not a prime number. 2. Circle 2 because it is a prime number and cross out all the multiples of 2 like 4, 6, 8 and so on. 3. Circle 3, the next prime number. Then cross out all the multiples of 3 like 6, 9, 12 and so on. Numbers already crossed need not to be crossed again. 4. Circle the next prime number which is 5. Then cross out all the multiples of 5 like 10, 15, 20 and so on. 5. Circle the next prime number which is 7. Then cross out all the multiples of 7 like 14, 21, 28, 35, 42, 49, etc. 6. Then encircle each of the remaining numbers. The numbers circled are prime numbers and rest are composite numbers. This method of finding prime numbers is known as using the sieve of Eratosthenes. Prime factorization, prime factors. A factorization in which every factor is a prime is called the prime factorization of the number. A prime factorization of 15 is equal to 3 into 5. Prime factorization of 18 is equal to 2 into 3 into 3. B. Which of these products is the prime factorization of 24? A. 4 into 6. B. 2 into 2 into 2 into 3. C. 2 into 2 into 6. Solution. A. 4 into 6 is not prime factorization as 4 and 6 are not prime numbers. 2. 2 into 2 into 2 into 3 is the prime factorization of 24 as 2 and 3 are prime numbers. C. 2 into 2 into 6 is not prime factorization as 6 is not a prime. There are two methods to find out the prime factors of a number. 1. The factor tree method. 2. The division method. The factor tree method. In this method, we start with the smallest prime factor and then go on to find all the other prime factors. A. Find the prime factor of 54. First step. Find the smallest prime factor of 54. It is 2. 54 is equal to 2 into 27. Second step. Find the smallest prime factor of 27. 27 is equal to 3 into 9. Third step. Proceed like this till you get the last factor also a prime number. Circle only the composite numbers. Hence, prime factors of 54 is equal to 2 into 3 into 3 into 3. B. Complete the prime factorization of 60 shown here. 60 is equal to 2 into 30. 30 is equal to 2 into 15. 15 is equal to 3 into 5. Therefore, the prime factors of 60 are 2 into 2 into 3 into 5. The division method. In this method, the given number is divided by the smallest prime number by which it is divisible. Example 5. Find the prime factor of 120 by the division method. Solution. First step. Divide 120 by the smallest prime number which divides it without leaving any remainder. 120 divided by 2 is equal to 60. Write the quotient below the number. Second step. Again divide 60 by the smallest prime number which divides it without leaving any remainder. 60 divided by 2 is equal to 30. Third step. Proceed in the same way till you get the last quotient a prime number. Fourth step. List all the prime factors as a product. 2 into 2 into 2 into 3 into 5. Hence, prime factors of 120 are 2 into 2 into 2 into 3 into 5. Highest common factor, HCF. We can see that 1 is the common factor of any two numbers. The largest common factor of two or more numbers is called the highest common factor. A. Find highest common factor of 12 and 18. The factors of 12 are 1, 2, 3, 4, 6 and 12. The factors of 18 are 1, 2, 3, 6, 9 and 18. 1, 2, 3 and 6 are the common factors of 12 and 18. So, highest common factor of 12 and 18 is 6. B. Find highest common factor of 12, 14 and 16. The factors of 12 are 1, 2, 3, 4, 6, 12. The factors of 14 are 1, 2, 7, 14. The factors of 16 are 1, 2, 4, 8, 16. Here, 1 and 2 are the common factors of 12, 14 and 16. That means the highest common factor of 12, 14 and 16 is 2. Prime factorization method. Take the two numbers 12 and 28. To find the highest common factor of 12 and 28 using prime factorization, follow the steps given below. First step. Find the prime factors of the given numbers. Prime factors of 12 is equal to 2 into 2 into 3. Prime factors of 28 is equal to 2 into 2 into 7. Second step. Take the common part of the two sets of factors. It is 2 into 2. Third step. Find the product. 2 into 2 is equal to 4. Therefore, highest common factor of 12 and 28 is 4. So we must remember, if there is no common prime factor, the highest common factor is 1. Highest common factor of two or more numbers is always smaller than or equal to the smallest of the numbers. Division method. There are two division methods for finding out the highest common factor of numbers. Common division method, long division method. Highest common factor using the common division method. To find the highest common factor of 36 and 48 using the common division method, follow the steps shown below. First step. Divide the numbers by the smallest common prime number, which divides them exactly without leaving any remainder. 36 divided by 2 is equal to 18 and 48 divided by 2 is equal to 24. Write the quotients 18 and 24 below the numbers. Second step. Now divide the quotients obtained in step 1 by the smallest common prime number, which divides them exactly without leaving any remainder. 18 divided by 2 is equal to 9 and 24 divided by 2 is equal to 12. Third step. Do the same till there is no common prime number with which the quotients can be divided. Fourth step. Find the product of all the divisors you get. The product you get is the highest common factor of the given numbers. 2 into 2 into 3 is equal to 12. Therefore, highest common factor of 36 and 48 is 12. Highest common factor using the long division method. To find the highest common factor of 55 and 143 using the long division method, follow the steps shown below. First step. Divide the bigger number 143 by the smaller number 55. Second step. Take the remainder 33 as the new divisor and the previous divisor 55 as the dividend. Third step. Divide the new dividend by the new divisor. Take the remainder 22 as the next divisor and the previous divisor 33 as the next dividend. Fourth step. Proceed in the same way till the remainder is 0. Fifth step. The last divisor 11 is the highest common factor of 55 and 143. Therefore, highest common factor of 55 and 143 is 11. The highest common factor of 27 and 40 is 1. Such numbers are called coprime. Can you find some other coprimes? Lowest or least common multiple, LCM. Earlier in this chapter, we have discussed common multiples of two or more numbers. The smallest of these common multiples is called the lowest common multiple, LCM in short. For example, multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, and so on. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, and so on. We can see that 6, 12, 18, 24 and so on are common multiples of 2 and 3. 6 is the smallest of these common multiples. Therefore, the least common multiple of 2 and 3 is 6. Thus, the lowest common multiples LCM of two or more numbers is the smallest number that can divide those numbers without leaving any remainder. LCM can be found by the following two methods. 1. The prime factorization method. 2. The division method. Prime factorization method. To find the LCM of 15 and 18 using the prime factorization method, follow the steps given below. First step. Find the prime factors of both the numbers. Prime factors of 15 is equal to 3 into 5. Prime factors of 18 is equal to 2 into 3 into 3. Second step. Take the common factors in both the sets of factors. It is 3 only. Third step. Now take the remaining prime factors of the two numbers. They are 5, 2 and 3. Fourth step. Find the product of all these factors. 3 into 5 into 2 into 3 is equal to 90. Therefore, least common multiples of 15 and 18 is 90. Division method. To find the LCM of 3, 12, 18 and 24 using the division method, follow the steps given below. First step. Divide the given numbers by the smallest prime number that divides at least two of them without leaving any remainder. 12 divided by 2 is equal to 6. 18 divided by 2 is equal to 9. And 24 divided by 2 is equal to 12. Write the quotients below the numbers and bring down the number which is not divisible. Second step. Again divide the numbers, the quotients in step 1, by the smallest prime number that divides at least two of the numbers without leaving any remainder. 6 divided by 2 is equal to 3 and 12 divided by 2 is equal to 6. Third step. Proceed in the same way till there are only prime numbers or 1 in the last row. Fourth step. The product of all the divisors, prime numbers and the numbers in the last row is the LCM of the given numbers. In our example, it is 2 into 2 into 3 into 3 into 2 is equal to 72. Therefore, LCM of 3, 12, 18 and 24 is 72. Tests of divisibility. Suppose you are to check whether you can divide a number, say 15,746 by 2. Normally, you would divide 15,746 by 2 to verify whether it is exactly divisible. But there are some easy methods to check divisibility. We shall learn some of them here. Look at the ones digit of the number 15,746. It is 6. We know that 6 is divisible by 2 as 3 into 2 is equal to 6. Therefore, 15,746 is also divisible by 2. We shall verify whether it is true or not by actual division. We see that 15,746 divided by 2 is equal to 7,873 with no remainder. Hence, 15,746 is exactly divisible by 2. Divisibility by 2. From the above example, we conclude if the digit in the ones place of a number is divisible by 2, then the number is exactly divisible by 2. We know that if a number is divisible by 2, it is an even number. The digit in its ones place will be 0, 2, 4, 6 or 8. Hence, a number is exactly divisible by 2 if the digit in its ones place is 0, 2, 4, 6 or 8. Examples: 98, 372, 4190, 74,156, 5,28,138. Divisibility by 3. Let us verify by actual division whether the number 9,753 is exactly divisible by 3. We see that 9,753 divided by 3 is equal to 3,251 with no remainder. Therefore, 9,753 is exactly divisible by 3. Now find the sum of all the digits of 9,753. The sum of the digits is equal to 9 plus 7 plus 5 plus 3 is equal to 24. We know that 24 is divisible by 3 as 8 into 3 is equal to 24. Thus, this example suggests the following rule to check whether a number is exactly divisible by 3. Find the sum of all the digits of the given number. If it is divisible by 3, then the number is exactly divisible by 3. That is, if the sum of the digits of a number is a multiple of 3, then the number is exactly divisible by 3. Examples: 72, 330, 4,896, etc. Examples: A. 72 as 7 plus 2 is equal to 9, a multiple of 3. B. 330 as 3 plus 3 plus 0 is equal to 6, a multiple of 3. C. 4,896 as 4 plus 8 plus 9 plus 6 is equal to 27, a multiple of 3. D. 72,324 as 7 plus 2 plus 3 plus 2 plus 4 is equal to 18, a multiple of 3. E. 5,18,904 as 5 plus 1 plus 8 plus 9 plus 0 plus 4 is equal to 27, a multiple of 3. Divisibility by 4. Let us divide the number 79,536 by 4. We get 79,536 divided by 4 is equal to 19,884 with no remainder. It means that 79,536 is exactly divisible by 4. Now look at the digits in its tens and ones place. They are 3 and 6 respectively. The number formed by these digits is 36. 36 is a multiple of 4 as 9 into 4 is equal to 36. Now divide 5,700 by 4. We see that 5,700 divided by 4 is equal to 1,425 with no remainder. It means that if the digits in the tens and ones place of a number are zeros, then also the number is exactly divisible by 4. This suggests a rule to check the divisibility of a number by 4. It is, if the number formed by the tens and ones digits of a number is a multiple of 4 or both of them are zeros, then the number is exactly divisible by 4. Examples: 928, 2072, 5,73,100. Examples: A. 928 as 28 is a multiples of 4. B. 2072 as 72 is a multiple of 4. C. 5,73,100 as the tens and ones digits are zeros. D. 91,524 as 24 is a multiple of 4. Divisibility by 5. Let us find some multiples of 5. 20 into 5 is equal to 100. 21 into 5 is equal to 105. 22 into 5 is equal to 110. 23 into 5 is equal to 115. 24 into 5 is equal to 120. 25 into 5 is equal to 125. Do you find anything in the above multiples of 5 that interests us? Look at the digit in the ones place of every multiple. It is either 0 or 5 and no other digit. Thus, we can form a rule to check the divisibility of a number by 5. It is, if the digit in the ones place of a number is either 0 or 5, then the number is exactly divisible by 5. Examples: 725, 5,610, etc. Examples: 725, 5,610, 89,150, 1,34,565. Divisibility by 6. 6 is equal to 2 into 3. Now, we shall find a few multiples of 6. A. 4 into 6 is equal to 24. B. 6 into 6 is equal to 36. C. 18 into 6 is equal to 108. Since these numbers are multiples of 6, they are divisible by 6. Check whether they are divisible by 2 and 3 also. A. 90 is divisible by 2 as it is an even number. 9 plus 0 is equal to 9, a multiple of 3. So, 90 is divisible by 3. B. 78 is an even number. So, it is divisible by 2. 7 plus 8 is equal to 15, a multiple of 3. Therefore, 78 is divisible by 3. C. 102 is an even number. So, it is divisible by 2. 1 plus 0 plus 2 is equal to 3, a multiple of 3. Therefore, 102 is divisible by 3. In all the cases, we see that the numbers are divisible by both 2 and 3. Hence, we can form the following rule to check the divisibility of a number by 6. If a number is divisible by both 2 and 3, then it is exactly divisible by 6. Or, if the number is even and divisible by 3, then it is exactly divisible by 6. Examples: 924, 87, 342. Examples A. 924. 924 is even. 9 plus 2 plus 4 is equal to 15, a multiple of 3. B. 87,342 even. 8 plus 7 plus 3 plus 4 plus 2 is equal to 24, a multiple of 3. Divisibility by 9. Take some multiples of 9. 12 into 9 is equal to 108. 73 into 9 is equal to 657. Add the digit of these multiples of 9. 108, 1 plus 0 plus 8 is equal to 9, a multiple of 9. 657, 6 plus 5 plus 7 is equal to 18, a multiple of 9. It means that if a number is divisible by 9, the sum of its digits is also divisible by 9. Hence, to check whether a number is divisible by 9, verify whether the sum of its digits is divisible by 9. Therefore, the rule is, if the sum of the digits of a number is a multiple of 9, then the number is exactly divisible by 9. Examples: 900, 1881, 29,745, 4,81,203. Divisibility by 10. We know that any multiple of 10 will have its in ones place 0. Therefore, to check the divisibility of a number by 10, just look at the digit in its ones place. If the ones digit of a number is 0, it is exactly divisible by 10. Examples: 460, 8,010, 14,200, 3,96,740. Trixie. Look at the pattern of numbers. Fill in the boxes with the missing numbers.